Thanks, Angelica. Thanks everyone for joining today. Taking a look at the agenda, first we're going to start with a brief overview of GDPR. Hopefully by now everyone who's joined is aware of GDPR and has a good idea what it's about, but we'll cover it really briefly. We're not here to give a lesson on GDPR, and we're definitely not here to give legal advice about GDPR. So if you don't know what GDPR is, or you're not comfortable with what you might need to do to be GDPR compliant, when we send out the presentation and our notes afterwards, there will be some links to documentation you can use. After that, we'll talk about why Neo4j is such a great fit for GDPR solutions. We're going to take a look in the Neo4j browser at the Neo4j Privacy Shield solution, which is a framework or an accelerator that we've developed for GDPR situations, or even more generally for data lineage and data governance situations. Then we'll take a look at some sample reports that you could run on the back of a system built on Neo4j for GDPR, and we'll wrap up with some Q&A. So first, onto our GDPR overview. Everyone has been in a bit of a panic for a while now about GDPR. It's a big deal. It's not something to be taken lightly, but hopefully by now everyone's comfortable with the regulation and is prepared. GDPR stands for the General Data Protection Regulation. It was adopted by the EU Parliament on the 24th of May, 2016, and comes into effect the 25th of May, 2018. So there was a 2-year window between when it was adopted and announced and when the regulation actually kicks in. But there's only about a month to go. So if you're not ready for GDPR, now is the time to finish up. The GDPR applies both to controllers and processors of data. So it's not always just the owners of data or the people who collected the data who can be covered, but also anyone who processes that data on their behalf. So it actually covers quite a few types of organizations, and it's not just organizations operating within the EU. Even though it is an EU regulation, it affects organizations outside the European Union that offer goods and services or handle data for individuals within the EU. So that's actually quite a broad set of companies that could be affected by the regulation. It does cover a broad definition of personal data. So obviously personal data would be things like your name and your address and your phone number and things like that. But even things like IP addresses or anything that could be used to identify you after the fact. You know, even if it's data that's been pseudonymized or tokenized, if you can convert that data back into a way of identifying a person, that would also be considered personal data. So the GDPR, it defines what are lawful bases for processing personal data. Sometimes that might be meeting a regulatory requirement. So obviously if you're a bank or a financial institution, you need to maintain information about individuals and you know, where they've sent money or so forth. And then other times it could be that someone has given their consent for you to use their data, or that you have a contract with somebody and you need their data in order to be able to fulfill the terms of your contract. So there's a number of different reasons that you might have that data. And then obviously you need to use that data accordingly and to keep it safe and prevent data breaches. And then finally, the GDPR defines very significant fines for non-compliance. So the fees could be 20 million euros or 4% of global turnover, whichever is higher. So, you know, even small companies would have to pay a very significant fine. If you're a large multinational company, the fines could be really quite astronomical. So this is the reason why I think there's been a lot of panic recently as people get ready for GDPR compliance, because no one's really sure how that's going to play out, and the fines and penalties are really quite significant. GDPR defines a number of rights for individuals, you know, European individuals whose data is being processed, and it can sometimes feel a bit confusing. You know, there's the right to rectification, the right to be informed of access, erasure, processing, so on and so forth. but it really breaks down to kind of a pretty simple spirit, and these are things that companies should be doing with the data they process anyway. You need to know what data you have. You need to know that that data is accurate. You need to know where it's stored, how and when you obtain that data, why you have that data, and whether or not you have the right permissions to use it, the person who's given you that data, who that data belongs to, and for what specific purpose. Who has access to that data? Is the data secure? How does it travel through your systems? Where does it move? And does it ever cross international borders? Sometimes that's quite an important consideration, data sovereignty and where the data lives. So if you were to summarize the GDPR, that kind of wraps it all up. And it really, as I said, is things that you should be doing ideally with your data anyway, right? And this is where the idea of turning GDPR from a regulatory requirement and a risk that you need to mitigate into a competitive advantage comes from. So if your approach to GDPR is that you're going to do the minimum to get by, stand on the sidelines, see what others are going to do before you move, focus on just the regulatory requirement, you might cover your requirements and not get in trouble with the law, but it ends up being kind of a regulatory cost and you don't really get any benefit out of it. Whereas if you treat this as a way of investing in your data governance and your data infrastructure, you turn that spend into strategic spend. And you can look at ways that you can actually then leverage that solution, leverage the control and insight you have into your data, and turn that into a competitive advantage. Sometimes that could be new ways of using your data, better understanding of your customers. It could be that you're creating a great brand for yourself. We've all seen in the news companies like Facebook and others are really getting beaten up for not being clear about how they're using their data. Whereas if you are clear with your customers about how you're using their data and what you're doing with it, and having that open dialogue with them, you could actually end up with a much better, customer satisfaction score, much better brand in the marketplace, and then you can leverage that to your advantage. So why is Neo4j a great fit for GDPR solutions? So as we'll see, GDPR really needs an understanding of connected data. Many organizations, especially large ones that have grown up organically over a number of years, have data in a number of places and all sorts of types of data in different places. It could be coming in from third parties. It could live in a number of different systems across your organization and across the world. And having an understanding of all those connections between data is actually really difficult to do unless you're using a graph database, which is made for connected data. And in fact, Neo4j is the #1 database for connected data. It's built from the ground up to manage highly connected data, to treat the connections between data elements as importantly as the data elements themselves, and to be able to do that at scale and with great speed is what Neo4j is engineered for. So as you can see, as I said before, tracking data across a number of systems can be quite tricky to do using more traditional database technologies or visualization technologies. But with the focus on connected data that Neo4j brings, along with a number of other powerful tools that come as part of the database, it becomes a much easier thing to achieve. Ultimately, what you're trying to do is be able to respond to GDPR requests quickly, to be able to understand your data lineage in a smooth, and continuous way, to be able to do all of this without spending a lot of money and a lot of time. And Neo4j enables all of those things compared to more traditional relational databases or even other NoSQL databases, which just aren't as good a fit for this sort of a problem. So we'll take a look at Privacy Shield. We're going to hop into the Neo4j browser in a minute and take a look at the schema and some of the data that we have loaded. But just to give you a feel for what we're going to be looking at, this is a randomly generated and curated data set. So this isn't from an actual customer or an actual organization, but it is a pretty large data set. There are 1 million subjects in the database. Subjects would be people whose data would be held. There are 2,000 users, so those would be individuals who have access to that data within the fictitious company Netfilms that we'll be looking at. 8 systems and 12 locations around the world in which that data is held. The data is for 10 years, so quite a long time. 8.8 million data movements, 1.1 million consents provided by those subjects, and in total, almost 14 million nodes and 50 million relationships in the database. So not super huge, but of a pretty good size, and considering that it's running on my desktop, on my laptop computer using Neo4j desktop, even at that size, the performance we'll see, I think, on the whole will be pretty good. So with that, let's have a look. Okay, so hopefully you can see here. First, we'll take a look at the overall schema that defines how we've entered the data into the database. And there's quite a bit going on here. So what we're going to do is break this down into kind of smaller views and take a look at all the different slices that we can take of the data and the different ways we can look at it. But here in yellow, we have person nodes, people nodes. These are individuals for whom we have data in the system. Around them, we have different types of data, and we'll cover that a little bit more. Data about individuals are stored in systems. Those systems have applications. Those applications live at a certain location in a certain country. Users have access to those applications. Over here on the lower right, we have some third parties and partner organizations, lead sources. Data could move either from or to these external sources, and we can track import and export, as well as internal data movements. And then we have consents that are provided by individuals for the use of their data by Netfilms. Okay, so to break this down a little bit into more usable chunks, I guess, this is the representation of a person and their data. We can see that we have 3 different classifications of data. So in this example, Netfilms categorizes personal information into 3 different classifications. One is basic information, which is here. That's things like name, address, email, so on. Then there's classified information. Classified information would be credit cards, billing address, passwords, so really sensitive information that would need an extra layer of security and more restricted access. And then the third group of types of information is activity information. And those are things like likes, viewing history, subscriptions, things that take place, interactions between the users and either the Netfilm site or a mobile app. Okay, we can take a look at one user's graph. We can see here, while the people do have a first name and a last name, of course, we're anonymizing this, so in our display we're not actually showing any of the information. So you can see that this anonymous person has some classified information, some basic information, and some activity information. The basic information and the activity information are stored in a SAP HANA system. And if you look at the bottom of my browser, you can see that lives on an Amazon instance. It's in Amazon's US West zone. There are several applications that are connected to that. So there's a marketing application, an advertising application, and a Netfilms analytics application. EU West is in North California in the US. There's also an Oracle instance that lives in US West. with some more applications off of it. So you can get a sense here for what kind of information we have about this person, what system that lives in, where in the world that system lives, and what applications have access to that. We can take a look at the Netflix systems schema. So this describes, kind of as we've just seen, where Netflix has applications, so where the servers physically live in the world, what applications are connected to those, and where those applications run, and in which country. So this gives a kind of a graph of the systems for Netfilms, and helps answer questions like, where does someone's data live? If the data moves between two applications, does that cross international boundaries? Quite important for GDPR compliance. Okay. If we wanted to see internal movements, the schema would look like this. So we have a person. The data of that person has an internal data movement node. So that represents that physical movement of data, when that movement happened, and between what systems. Right? And again, this is really important for GDPR compliance, but also for data lineage more generally. Being able to understand how data moves around your organization will help you improve your data governance and help you understand what systems touch what data. Then we'll take a look at some more very quickly. We won't get into many examples of them, but just some other ways that we can model data. We can take a look at data access. So understanding what users within your company are accessing what data about people. So we have a person, we have a data access event, the user who accessed that data, and from what application, where that access took place and when. Similarly, you can take a look at when data was updated, again, for data lineage purposes as well as GDPR compliance. It's important to know not just when you got data, but when it was updated, so that you can keep track of changes in your data over time. You'll want to know, what system, what application made that update, even kind of, was it your original load of data? Is it something that changed over time? Or as we'll come on to a bit later, there can be a forget request, right? So one of the rights granted to individuals by the GDPR is the right to be forgotten. And so you'll need to be able to understand when you've deleted that data. Importing data. So data can come from a number of other places. Here we see Netfilms can get data from lead generation sources. So you want to be able to understand where that data came from, what system it was stored in, and who that was about, so that you can make sure that all of your lead sources have the right to share that data with you, and that you can track back where your data came from if it wasn't generated internally. Conversely, there's also data exports. So you can share data with your partners or with third parties. When we take a look at consents a little bit later, you can see, you want to know where you're sending your data, make sure that you have the right to send data to that partner. And then you'll also need to know, if someone updates their data or asks to be forgotten or changes the privileges that you have regarding their data, that you can update all of the partners that you've sent their data to appropriately. And then finally, we'll take a look at consents. So even now, not necessarily even as a company who might be interested in GDPR compliance, but just as someone perhaps who's in the EU and subject to GDPR now, you might be getting a lot of emails about opting in, giving consent. Certainly I have. So this is quite an important feature of systems for GDPR compliance, is understanding who has given you consent to data, what they've consented to, and then being able to manage those consents going forward, either to change them or remove them as someone asks to be done. So here we have people, the consents they've given, the type of consent they've given, the usage that consent enables, and again, when that consent was granted. And here we'll take a look at a few sample consents just to bring that to life a little bit. So for Netfilms, if you consent to their terms and conditions, that enables recommendation generation. So they can recommend films to you based on other films you've watched or that your friends have watched. And also it enables the Netfilms player to report back to the network. And that's built into their terms and conditions that you would accept when you sign up. If you consent to having your Google account linked with Netfilms, then that enables sharing info with Google. It also enables generating advertisements, and the same goes with Facebook. If you link your Facebook account to Netfilms, it generates advertisements, and then it also allows you to share info with Facebook. You can consent to having your location tracked, in which case that enables tracking location. And then the last type of consent would be information subscription, which allows them to send you new release info. So as a user in Netfilms, if you consented to all of those things, it would allow them to use your data for all of those purposes that we just went through. And then if you revoked any of those, for example, if you said you didn't want tracking enabled, which we'll actually look at a little later, then that would mean that Netfilms was no longer able to track your location because you revoked that consent. Okay, so now that we've taken a look at all the different ways that we can store and represent and query data in terms of the model, we'll take a look at some examples from a user perspective. So first we'll take a look at a user that we'll call Jesse. We'll review the consents and usages for the data that Jesse has in the systems for Netfilms. So here's Jesse in the middle. Again, even though Jesse does have a real first name, we've anonymized it in the display because that would probably be quite typical of a normal usage, normal data access. We have a few consent events. So here, American date format. So this would be January 9th, 2015. Jesse consented to info subscription and can now, Netfilms can now send new release info to Jesse. On December 17th, 2013, Jesse accepted the terms and conditions. And on October 20th, Jesse consented to having location tracking enabled. And so that usage is also enabled here. If Jesse then decided, I don't want my location tracked anymore, I'm going to revoke the consent for tracking that location, we can record that in the system. So here's Jesse, here's a new event, location tracking has been revoked. Right? And then, of course, naturally, there would be probably some sort of integration with underlying systems. You would want to cascade that down to your operational systems. There would probably be at least some flags that you'd have to set or some data that you'd have to remove or update in some of your underlying systems to reflect that change. But here in the graph, it's easily done by changing the relationships. And then if we take a look at what we call the personal data map for Jesse. where we can see kind of a full set of data about Jesse in the system. You'll notice that we've got the 3 other consent types here. Here's the revoked tracking enabled. The other ones are still provided. And we can see now also a lot of information about various movements of data, data updates that have taken place around Jesse. So this is something that you could actually provide to your end users, as well as provide to data protection authorities who might who might audit you or check your compliance, right? It's a really easy visual way on one page of understanding not just the consents that you've received and when you receive them, but also movements of data, updates of data. We can double click on one of them and we can see here, we've got a data update. That data update happened in the SAP HANA system. The application was NetFilms Online. It happened in September 2016. It was an update to the activity information and the basic information. So it's quite easy to navigate around, understand what happened and when, but also a very graphical way of representing that either to your end users who might request this information from you as part of the rights they have under GDPR, the right to be informed, or again to a data protection authority who might come asking for this sort of a data representation. We can also take a look at the right to be removed, removing all information about someone. So here we have another user, we'll call him Peter. Peter at some point had some sort of interactions with NetFilms. Perhaps he used a trial, or perhaps he was a full-blown user, but he's no longer a customer of NetFilms and has decided that he doesn't want them to hold any information about him any longer. So here we can see currently in the system, here's our user Peter. We've got some classified information on him that's stored in this Oracle system in US West. Then we have some basic information and some activity information that's stored in SAP HANA. If he were to send a forget me request, we can process that in the graph. Again, that would have to cascade to the underlying systems, but because we know where that data is held and what data is held, we can see that very easily in the graph. It becomes a lot easier to understand where you need to go and delete that data. Okay, so in the graph, we have processed the forget me request for Peter. We can take a look at the data that we have for him again, and we can see in the graph, there's no more data connected to him, right? We've processed that forget me request, and we no longer have that graph of data about Peter. Okay, so lastly, we'll take a look at a few reports that you could generate out of Neo4j. So as you start collecting this sort of information, as I said earlier, it's a great way of using a regulatory requirement and a regulatory spend to actually create new value for your company, get new insight into your data, and improve your data governance. So we can take a look at the number of consents by country, and then you could use that to improve your business processes or maybe tweak your consents. If you start to see some of your countries are giving more consent or more of a particular consent than another one, you might want to take a look at whether the wording for that particular country is appropriate. Maybe there are cultural differences between those countries that mean you need to approach consent or usage differently. Maybe you need to test new consent types, but at least it gives you the information that you need to be able to respond appropriately. So we can see this is the one query that I have in my demo that takes a little while to run because it is processing millions of nodes on my poor little laptop. So it will come back with the result soon, and then we'll be able to see all the different types of consents that we have. by country. While that continues to run, we can see we also have a way of demonstrating system growth. So here we're looking at the Oracle system in EU Central 1, again running on Amazon. We can see how the system grows year on year. So as we start tracking data movements around our systems and around our infrastructure, we can then understand what systems are growing and how much, where data is consolidating, and then that can give us metrics that we can use then to plan future infrastructure upgrades or understand how best to maintain and build out our systems. We can see as well, here's the list of consent types by country. If we take a look, for example, by terms and conditions, everyone has to accept those, so that it's one accept per person. But if you take a look at track location enabled, for example, in France, you get 0.16 acceptance per person, so probably roughly 7 or 8 people are presented with track location enabled for everyone that accepts. That number is significantly lower in Germany, and then much higher in the US. So we can judge from that either people in the US are more comfortable with having their tracking, their location tracked, or perhaps there's something wrong with the way that it's being presented in Germany, either in the wording or the way it's presented, and so that could be improved perhaps by changing something about the terms and conditions there for Germany. Okay, we'll take a look here at a sample data lineage report. So this again would be something that you might need to provide to a regulator, right, to be able to demonstrate to them that you know how data has entered your system for a particular subject and everything that's happened to that data since it entered. So here we can see every step along the way, from consent being given, data being updated, data being exported, so on and so forth, right? So you could provide that to the regulators as part of your compliance requirements. And then again, we've also seen that you can see that as a graph, right? Something that can either be visually exploded and saved as a file, or put into some kind of a portal or a front end for end users or data protection authorities to be able to access directly. Okay, so that's the end of the demo. Now we'll take a look at some sample reports that could be built on top of a system like this, right? So again, looking for ways to turn your regulatory requirements into opportunities. We took a look at some of that in the graph, being able to understand things like data movement patterns. Maybe that will help you understand threats, when you can start to understand how data, especially sensitive data, is being accessed across your organization, from where and by who. That might give you insight into inside threats, people who are accessing data inappropriately, depending on the nature of your business. That could be a serious threat. You can look at data usage reports. There's all sorts of ways that understanding your data better can improve your business, and help you function operationally much better. So for example, we've looked at some of the personal data map information for some of the users in the system. If you chose to, you could expose a view of a subject's data to them directly. It would be a great way of giving them confidence in the data that you have and allowing them to manage their consents and their data directly. That would remove presumably some of your support load. I imagine there are some companies out there that are actually going to have entire departments to manage GDPR, at least a reasonable workload. So if you can put some of that into an automated fashion with a front end directly for your subjects to access, makes it easier on you and also gives them the transparency that they're going to want. You can also provide internal management views. So a view, again, of data access by location, data lineage reports for data governance, for being able to understand perhaps data quality issues, or identifying golden sources of information within your organization, understanding consents by location, some of the things we've already looked at. And then finally, again, data access inconsistency reports. So, looking for patterns of data access in your organization that may be inappropriate, that actually, might be against, might go against regulations or corporate policy, and then that gives you the information that you need to then be able to change the situation, either change permissions, change how data is accessed in your system. Okay, so that is the end of the demo. I'll open it up to Q&A.
Okay, thank you, Joe. So just a reminder to everybody, if you do have a question, there's the questions box on your GoToWebinar control panel. So you can just type it in there and I'll try and read a few aloud. So we have one. So Joe, can you append data stewards and data owners and their role level, as well as their specific data ownership responsibilities to a finance application?
Yes, so it would, yeah, it's not modeled in this particular demo, but you absolutely could add those sorts of roles into the system. Especially if you're looking at data lineage, it would be important to know, is there an owner for a particular system? If that system is the golden source of a particular type of information, who owns that? Who are the stewards for that data? Who manages it? Who needs to make updates and so forth? And then you could layer, onto that some permissions, right? Who has the ability to update certain bits of information, or indeed who has the ability to see certain types of information.
Okay, great. And if you're using Neo4j, does that work well with other databases as well, or do you typically see people using only Neo4j for this type of solution?
Neo4j absolutely works well with other types of databases. We do often see, a situation where there's polyglot persistence, where there's a number of different databases in an environment, each one of them handling a workload that's suited to its particular design. So certainly always relational databases. Relational databases have been here for decades, and they're not going anywhere anytime soon. So relational databases are always in play, and those tend to be the systems of record, the operational systems that this sort of information comes from, and that we were mapping in this example. And then there could be other types of databases. Maybe there's Hadoop, maybe there's a document database, and Neo4j fits well into all of that, right? What we looked at today was a map of where information lives and how information moves across an enterprise. And so any of the systems in that could be any type of database or any type of application. And then Neo4j can communicate with those, very well. There's JDPC connectivity. The ability to import from relational databases is very straightforward, but also other types of databases, Hadoop. There's a lot of tooling that comes with Neo4j for interacting with those types of databases, and it fits very well into that sort of a multi-database design.
Okay, and I know that in GDPR there's kind of a different set of rules around sensitive data, so data pertaining to somebody's religion, race, gender, that sort of thing. So do you know if there's a way to classify sensitive data and identify required security policies to apply only to those nodes or that data set?
Yeah, so we looked in the example today at 3 different ways that NetFilms classified data, right? And I think that's probably a pretty good approach. You could make that more nuanced or more finely grained. So instead of just basic classified and activity information, you can have basic classified, sensitive, and activity information. It would just come down to really how you design the model and how you decided to kind of break certain bits of information out, into a sensitive group, and then you control access to that. Again, you'd probably want to anonymize some of it, or certainly restrict it to individuals or applications that had a clearly stated need for that information. But definitely possible, and it kind of would be an evolution of what we looked at today in the demo.
Okay, great. And what kind of input data is needed for Neo4j?
That's a big question. So I think you'd start by designing your model how you wanted to all this information to sit, kind of like we looked at in the beginning of this with the schema, and then basically you're feeding this information into Neo4j sort of in that format. So you could put text into a CSV file and load that into Neo4j. You could connect Neo4j directly to other systems who might inject that information, again over JDBC or something like that. Yeah, but ultimately it kind of comes down to how you design the model, and then feeding the information that you want into Neo4j, in some sort of a format that can be ingested, CSV, JDBC, from another database, something like that.
Okay, so there are a few different ways. So I have a question here about scale, essentially. So is Neo4j stable enough or capable to handle something as big as over 10 million users with all their personal data, plus perhaps data for business intelligence?
Absolutely. I mean, what we looked at today did have millions of nodes, millions of relationships, and that's running on my 2-core MacBook laptop. So we regularly see Neo4j scale to many billions of nodes, many billions of relationships. So scale, at least certainly on the scale that you just mentioned, would not be an issue. It might take more hardware than my laptop, but certainly you can either scale vertically by putting more hardware into play. You can also scale horizontally by clustering. So yeah, absolutely. Growing to a much bigger solution than we looked at today in this example is not a problem at all.
Okay, great. And are you able to either show us or elaborate on how you would connect an actual or reference data to the nodes of the graph? We're given an example here to load a taxonomy of systems or processes, that sort of thing.
Yeah, it won't be anything I'll be able to show today directly, but I can try to elaborate on it, I suppose. So you could either integrate directly with a reference data system and load data into Neo4j that way. You could model your reference data directly in Neo4j, I suppose, if you didn't have a system already and you were looking for somewhere to do that. But yeah, normally, I guess you would see something like that in a situation like this, where you have information about people and their accounts and so forth. There's always going to be reference data in play. So you probably would have a system that maintained that reference data already, and then you could integrate Neo4j with that system, either via an ESB or a direct connection. And read and write the reference data that way.
Okay. And then what is the Neo4j's data storage model? So is it on-prem? Is it cloud? What kind of options are there?
It's either, yeah. You can run Neo4j on-premise. You can run Neo4j on the cloud. There are definitely AMIs available on AWS. And I think as well on Azure there are images available. I don't think there's anything kind of ready packaged on Google Cloud just now, but basically Neo4j runs in a JVM. So anywhere that you can run a JVM, you can run Neo4j, and that can take place on the cloud. It could take place on premise, or it can be a hybrid environment, a mix of the two.